in relation with DevOps and so on. So I decided to go to the IT oracle of our days, Reddit, and I already found that there was a thread there that was called DevOps versus platform engineering, right? And I found a lot of type of opinions. All of them were really well documented and thought. You can find any kind of probably relevant answer there. This last one, I really like it. Class platform engineering is implementing interface DevOps. But at the end, I think DevOps brought us some meaningful values, right? Like breaking the silos, making our team self-sufficient, whatever it means, automation, continuous improvement, and so on. But what is the relation with platform engineering or with platform? It is evolution. It is a shift in the industry. Well, if we go back 20 years, we found that there was a company, a little company called Heroku. It was the first PaaS, the first platform as a service. And it was funny because at that time, the term DevOps was taking shape. So they were not far together. Heroku, what was interesting about Heroku and why it was adopted by many people is because it is a product, right? It is a product to deploy applications. At that time, it was only Ruby, but they were adding more runtimes. It was easy to deploy. They have good support. The user experience was great. You can have a CLI command, and within a minute, you can deploy your app and have a URL where you can see the front end. It was self-service in the way that you don't need to request anybody on your team for access to the tool. You can run it from your local. And they have a good support and good documentation. So it was easy to start with. It was also composable in terms of there were some integrations, and you could run your databases or queues together with the app. And they proclaimed that it was safe, right? So why we are not using nowadays all Heroku or AWS Elastic Stack or Google Cloud Run or any other PaaS? Well, in my opinion, I think when you are running a startup, those PaaS are really useful. But when you are getting bigger, it's more and more difficult to kind of accomplish all the requirements that the different teams in your company could have. So if you have a security team that wants to, for example, scan all your container images or all artifacts that you produce, make sure that they come from the right origins and they are signed and they are only be deployed in certain environments and certain regions, this is something really hard to achieve with a PaaS, right? So in the end, you see nowadays a lot of companies building their own platforms. But what is really a platform, right? When I was thinking on it, for me, something like this, like you have containers, all these containers are right-sized, they are connected, everything is bright and shiny, right? But I wanted to give you a more consolidated answer. So I went to the prophets of the cloud native, which are the cloud native complete foundation. If you have not been in a cave in the last year, this foundation is open source foundation that is kind of advocating for fostering the usage of cloud native technologies, right? And there are many groups inside which are called TACs, or technical advisory groups, and they are discussing and foster the different type of areas around the big landscape of the cloud native. And the funny thing is that they wrote a white paper that is called Platforms. I really encourage you to read it if you like the topic. And there they kind of went through all the reasoning why a platform is needed, which attributes the platform has, what how it looks like an ideal platform. And I took the diagram from the website. This is something like you see in a common platform. You have your product or application developer teams, which are on the top, and they are interacting with the platform through a set of interfaces. Those interfaces can be CLIs, can be directly APIs, can be web portals, can be documentation, or can be together with documentation or having project templates. But at the end, what the interface are doing is enable some capabilities of the platform. And capabilities could be something as simple as compute network storage, or can be a database, or can be an observability tool. These capabilities, what they're doing, are abstracting the infrastructure provider primitives. So not every developer should know how to build or instantiate a AWS RDS or any other kind of infrastructure, which is something usually not valuable for the end-up final developer, right? So something I really liked from the white paper was the principle that they state a platform should be built on. And the first one is that it should be a product. It means that you have to build a team, and this team should have a product owner and all the roles, and it should have a roadmap, and it has to go to the users that are going to use, listen to them, get the requirements. So really building like internal product, right? And it has to focus on the user experience, the same as we have talked in the past. The experience for the developer should be easy. Otherwise, are not going to use the platform, right? Then it has to provide also good documentation and good onboarding experience for them. And it should be self-driven. So anyone can use an API or CLI and can get an capability running on the platform. They don't need to issue or create a ticket in Jira or anything else to get something running. Also, for me, this is the most important one, is to reduce the cognitive load. This is what we were talking before. You don't need to expose all the details of the infrastructure to the developer. So the site-wide type of information and configuration you expose is probably the most important thing. And this is based on the knowledge that you have of your users. And it should be composable and optional, which means you don't have to enforce all the developers or all your teams to use your tooling and your capabilities. It should be like plug and play, right? I want to use the observability tool, but I don't want to use the CI. I have my own CI. I've been running my CI. I'm happy. OK, you don't have to enforce it to use everything from the platform, right? And then it should be security by default. So we have to make our security teams happy. So let's build a platform together. First of all, disclaimer alert. This is not a broad platform. So probably you will choose different tool procedures. But this is an experience I wanted to run for myself to learn how to do it. The first thing I have to do is build a team, right? The problem is I'm working in remote. So I'm working in a small place. And I don't have many people around that is technical. And since I've been talking about platforms with my family the last 2 years, I decided to make a little experiment and bring them to the play, right? So I choose a product owner, and I choose my wife because she's very good, like tracking all the tasks, following them up, talking to the people, like make the team cohesive. So this is my wife. I also wanted to have someone in the platform that takes care of the support, like it's marketing the platform to the users, it's writing documentation, it's follow-up, like solving the problems for the users. So this is my daughter, Luna. And then I need a SRE, right? A platform will have problems, and we will have someone to bug fix the problems and monitor the system. And this is my kid, Acher. And then lately, we need someone that builds the platform itself, have some knowledge about integration and languages. This is me. So we have a team, right? Let's start to building one. The first thing, after a long dinner in a Friday night, we were discussing about the white paper, the platform white paper, and the family, and we decided that the first thing that we need to do is to build a minimum variable product, right? This is what all the lean development is saying, and we want to build something that before we reach any user or potential user, right? What should be the very minimum thing when you build a platform? So what we came with was these 4 points. We need an infrastructure provider, a place to run the platform, right? We need an API, at least, to build, to be exposed to the users. We need a compute network storage capability because we want to run in the platform our own services to enable the users. And we need access management. We need to control who access to the platform, which rights this person have. So we built our first epic, and we start working on it. From the top to the bottom, we were thinking what infrastructure provider we can use. But in my family, we have a problem, which is we have a limited budget, right? So we need to do really well cost management. Also, my kids are not too familiarized with all the cloud native things, so I need something easy to start with, and that is simple. I didn't want to talk or explain a lot of things about cloud services, and I decided to use Docker in my own computer. So yeah, it's super easy to use and start with, right? Then we go to the platform API, right? So we need an API that is easy to extend and is easy to scale. And looking at the future, we can add more functionality on it, and it's not going to be a limitation. Most of you are already thinking about Kubernetes, which in reality is not just a container orchestrator, right? For me, it's more an abstraction layer to build platforms. I say that because Kubernetes allows you to create custom resource definitions. So if I want to design an application object or entity or resource, I can do it extending the API easily. And I can program my own operators, for example. So when a developer submits or apply an application, I can pull the application and I can install it. So I can offer this functionality. And something I like also about Kubernetes is the admission controller system, because it let me hook into the API process and validate or mutate the request, the objects that come to my desire. So if I have this application resource and I want to validate all the parameters that my users, my developers, are sending to me, I can decide, I can validate it or I can invalidate it if I want. And I can also default some of these parameters. So I don't need to, or my developers doesn't need to put all the information if they are not really required. Then what is great also is the community. It has a big community with allow us to get access to a lot of tools, open source tools. And it has usually a great documentation and UIs, so we can start quickly to iterate and build the API, right? In this case, we use Kind, because Kind is a project which runs in my computer and just requires Docker, can bootstrap a Kubernetes cluster super quick, and we can even take it down and bootstrap again, so we can do tests really easy. This is how it looks like the Docker desktop UI, and we have already a platform API and a platform running. So now we were thinking about the access management, and we wanted something that allows us single sign-on. So when we onboard new users, they can still use their identity provider, or they can use the identity provider they have. They don't have to migrate to anything, and we can plug him into the platform. But also, we want to audit everything that happened. So anyone that logs in the API, we want to have like a registry of what he has done or which action has been taken. Also, we want something that obviously running Kubernetes, because our platform is running Kubernetes. And I don't know in your family, but compliance in my family is a big deal, and we don't allow anything below SOC 2. So we found teleport was ticking all these checks. We implemented telecom in the platform. And then we define things like this role, where I can define which type of access a platform engineer or a developer, in the case of a developer, can have to the cluster. You can filter with resources or bind it to existing user group in Kubernetes. And easily, I can assign that to a group of people. Also, a part of integrated with identity providers, you can create your own users in case that there is a team that has a node identity provider. And you can check when someone has access to the cluster, because basically the teleport is issuing short TTL certificates every time that someone accesses. And you can check all the details there. And even if someone accesses to any node on the cluster, I can see what this person has executed. So if my son is like troubleshooting and access to SSH nodes, I can see what he's running. So now we have the diagram before, and we are starting like drawing some icons, which is what we like in the family. And we are covering some of the areas, right? And now we need someone to try out our platform. But as I told you, there is not a lot of people around. So I found that I have a neighbor, which is a Node.js developer. It's called Joel. And he's building a Node.js application, which is called Goodbye World. Don't ask me why. And he wants to try it in a dev environment, and that's how it works, right? He is quite new into all of the ecosystem. So we met him for a dinner, and we were discussing all the requirements that will be ideal to have in the platform in order to enable him, right? And one of the things we wanted to do is build, test, and package process. Also, we wanted to have an environment setup, a configured management, an application delivery, some observability, and it should be secure, have a secure baseline, sorry. Also providing some documentation and templating, always, right? So let's go start with the first one, build, test, and package. This is a clear scenario of a green field. So Joel has not a lot of experience, and we have the opportunity as a platform team to bring or offer him some kind of patterns or ideal practice how to build, test, and package applications, right? The first thing that we advised was to use containers, obviously, because it's kind of a standard. There is a lot of documentation out there how to build a container image with Node.js. And also, we decided to use GitHub Actions. The reason was because Joel already has the code in GitHub, so it was too easy to use GitHub Actions. And also, it can be our first CI supported by the platform. It's something that we don't have to run in our infrastructure because it's running in GitHub infrastructure. And also, it's not so expensive, and it's easy to use and pretty reliable. So we decided, OK, GitHub Action is going to be our first CI supported. And then we need also to distribute the container image, to push the image to somewhere so we can then download it to run it. And we stick to GitHub because GitHub offers you a GitHub registry, right? So you can directly push from the CI system to it. But how do we offer this to Joel, right? The easiest way that we thought is to create a template repository. Template repository with some golden files, like the ones that you see, like a Docker file or as workflow CI YAML. And as Victor showed us before, you can define which steps in the GitHub action you can run. Basically, in this very first version, we decided to just use npm to build, test, and push the container image to the registry, right? So we give to the template to Joel, and he can start building from that part. Now, we have to set up the environment, right? And talking to my family, I found that probably the easiest way is to use the same platform cluster, the kind cluster that we are running, with a new namespace, new resource quota, and some airbag there, and let Joel run the application there. But probably this is not really a good idea, right? Because we are mixing up our platform services with our developer workloads, and also it's not going to scale. What we want to build is something that is reproducible, ephemeral, configurable, and standard, so we can build environments dynamically. And for that, because we want to stick to Kubernetes, we went to an upstream project that is called Cluster API. It's part of the Kubernetes community. And what Cluster API offers us is a declarative way to build our clusters. So the same as we define deployments in Kubernetes, we can define clusters. And then we can do it in every provider that is offered or is supported by the upstream project, which is most of them. And also it runs Docker, so we can run it in my computer. And then the cool thing about Cluster API is that it gives you some controllers, so it allows you to manage the entire cycle of the cluster. So you can change configuration on the fly or scale it or delete it, and it's pretty easy to use. And also allow us to set what typology of the cluster we want and customize any configuration of the Kubernetes components. So we are using Cluster API together with Docker. And this is kind of the platform diagram that we will use. We have 3 controllers that come with Cluster API: control plane controller, which manages control planes of Kubernetes; Bootstrap, which takes care of all the bootstrapping of the cluster. And then we run the infrastructure controller that we want, in our case Docker, to build workload clusters on demand. So first of all, we created a dev cluster for Joel, or for next teams that want to join us in the journey. And a dev cluster definition looks like the one that you see here. You can define cluster networks with the pods and the service CDRs, which type of topology this cluster is going to have, what version of the Kubernetes will have, and also how many machine deployments or how many machines workers this cluster will have. Right? So we start with 3 here and with 131 version of Kubernetes. Now, we need to configure the image, right? The container image. We don't want to back in the configuration of the app into the container image. This is obviously not compliant for us, so we decided that we need an app package, something that kind of templates or kind of define all the configuration of this container and all the manifest of Kubernetes in a package. Also, we need a way to template this configuration so we can decide which type of, I don't know, service load balancer we will use or how many replicas. So we need a way to template. Also, we need a way to manage the releases, so roll back or roll out the release when you deploy into a cluster. And we wanted something that is open source and backed by community. And here we decided for Helm because it's pretty well supported and it gives us the possibility to define charts. This is a chart, like a boilerplate of a chart that we included in our template repository. So this is now something that Joel also is going to use. And it has some files already created, which have the typical deployment, ingress, but also has some helper functions. And in the helper functions, we kind of standardize what type of labels the app will have on an other type of metadata that we would like to kind of standardize in our company. And also has the values configuration, which is kind of the parameters that Joel's can configure. So this is the contract of the app, some way, like an interface. And in these values also can add a schema, so we make it compliant. We can even test it that there is not a chain that breaks this values schema. So this is an example of values YAML that we created for Joel. And here is just defining some properties like replica count, how many replicas of the app you want to run, the image, the ingress, so it can be different depending on the environment. We can set also the resources. We are setting limits and requests, as Ada advises yesterday. And then we pass to the application delivery. I was last week taking my kid from the activity, and he told me, Daddy, it's great to have Kubernetes, but it's really sad to use Helm install or kubectl apply to deliver an app. And I say, yeah, I totally agree. I don't like it either. And we were looking for solutions. And we think that there is now a trend that is kind of solidifying, which is called GitOps, right? And GitOps allow us to define declaratively version all our infrastructure and all our applications that are running in our infrastructure, right? So we think that this can bring a lot of value for us. It also comes with controllers, GitOps controllers, usually, that automate all the process, so ensures that this infrastructure and this application are up to date, and it make it consistent. Also, it helps us with the collaboration, so we can collaborate between teams using just Git repositories and common Git actions. And it allows also to do faster iterations, like small steps and building stuff bit by bit. So here we use Flags. We choose Flags over Argo CD and others because we think Flags is simpler. And it brings with some controllers, like the ones that you see here. We have the source controller, which is kind of the controller that pull all the Git repo code into the system whenever it's needed. And then together we have a Helm controller, which is the one that apply or install the applications into the right environment, in the right workload cluster. And then we have a notification controller, so whenever this workflow doesn't work or we have a problem, it will notify us. This is an example of a layout that we are using. This is a monorepo layout. It means that everything is in a single repo. And probably this is the fastest and easiest way to start with GitOps. There's many layouts out there, but this is the one I like it. I can define my cluster, my dev cluster, for example, here in YAML. And then every time from now on that I want to change a parameter configuration in my cluster, I just do a pull request to the repository. I can also add some infrastructure in this cluster, like an ingress controller or a gateway API. And then I can also push all the apps that I want to run in the cluster. So here we have the Goodbye World example, which contains a release YAML, which is not more than a Helm release. Okay? Helm release is an extension. It's a custom resource of Flags that allow us to install a Helm chart into the workload cluster that we want, or into the Kubernetes cluster that we want. You have to point to the right Helm repository. You can configure different variables, how you want that the Flags controller works. And then the most important one, you can also provide some values. So you can kind of define values for environment, like configuration bar environment here. Cool. So we have the app deployed into the workload cluster, right? But we need to give Joel some observability. We wanted to already build something in our platform for my son, so he can already check if the cluster is healthy or not. And we wanted to build it in the main platform. So it's running in the platform cluster and not split it in different places. And we decided to use an internal solution instead of a third party because money, because there is also a good open source project out of there. We wanted that the project also has the basic metrics of the system, so we can see if the machine is healthy, but also we want to make it extensible. So if Joel wants to add some metrics or some logs into the system, he could do it, right? And he can use the system also to create their own rules or their own alerts, even define their own dashboards, right? We can have even monitoring teams using our platform that define some custom dashboards. Then with a pull request, we could even add dashboards on the fly to the platform. And in the end, what we use is Prometheus and Grafana. It's nothing new, right? It's quite common, which is running in a flavor of Prometheus operator, which is creating an instance of Prometheus in our central cluster, in our platform cluster. And it scrapes metrics from all the workload clusters. At the same time, we have a dashboard controller, which kind of is reconciling dashboards into Grafana. So everyone is adding a new dashboard, it will appear there. And also, at the same time, is reconciling alerts and rules into the system. And in the end, what we are providing to Joel is a very basic dashboard to check CPU and memory, right? But we can extend it from here to whatever we want. So now we move to security part. And in this case, we wanted to use a policy engine because we like the idea of, based on the admission controller system of Kubernetes, to decide what type of resources can pass or be validated or enforced. And we wanted to extend the capabilities or the standards that Kubernetes gives you. Kubernetes comes with pod security standards, which is some basic standards that run in Kubernetes that offer baseline and restricted policies, but they are too rigid to my taste. You can only configure them by cluster or by namespace, but you cannot do it by app. And in order to manage exceptions for the application is not too easy, so we wanted something else. And following on the same approach, we wanted to have policy as code. So we wanted to include in our configured management repo our own policies, or we can let the other platform teams to define their own policies. So we enforce compliance. And then the cool thing that we wanted to look for is to have a CLI. So I think it's very disappointing for the developers when they are doing all this kind of journey to deploy the app, and when they reach the target, they have some security validation failing, right? And the reason is you could already inform your developers in the very beginning. So what we want is to have a CLI that runs in the CI and check all the policies that our platform has, and then in building time, Joel could know what things go well or what not. If you have a root container or anything wrong, you can fix it. And for that, we use Kyverno. And I show you a cluster policy, a Kyverno cluster policy, which again is an extension of Kubernetes that Kyverno brings. And this cluster policy is to verify the Git repositories. So what we are doing here in this policy with YAML, we are YAML engineers in the family, we are checking that all the repositories, the Git repositories, come from the same GitHub organization. Okay, this is just an example of cluster policy that we are using. So last part, documentation and templating. Yeah, I was talking to my daughter about how we can write this documentation. She is in love with Markdown. It's super easy to use. It allows you to add images, to add links. It's integrated with GitHub pages. So you create a docs folder, you push the content, and it's visualized in the doc hub of your project. Also, it led us to define a golden path. I'm not sure if everyone is familiar with the term golden path, but this is a term brought by Spotify, and it's what wants to tell us is define a process to build in your platform. So a standardized process to build in your platform. But it's not really like a template, like you have a template and you apply it. It's more like a process that is standardized, and it has an owner, is maintained, is tested, and everyone can collaborate, but it's something that is working. It's not something that you build once and you forget. And also, it has a clear target audience, and it's a step-by-step guide. And this is what we try to create for Joel. So now we have the same architecture diagram than before, but we have more icons, right? We are adding more and more capabilities. We are getting there, right? But the problem is, last night, Joel came quickly to my home, and he was a bit in panic because he forgot something we need to provide him. He's using a relational database, a Postgres database, to run the application, but he forgot totally, right? He was using AWS, RDS for that, and he was building it manually, ClickOps. But we don't want to do that for Joel. We want to integrate it into the platform. So we were thinking about what we need to do. And kind of the two requirements here are we need a way to bind services to the workloads. And at the same time, we want to manage external resources like AWS RDS, also within the platform. So how we do it? Well, we wanted to have like a mechanism in Kubernetes also to define these resources, right, like AWS RDS. But we don't want to have just the AWS RDS object. We just don't want to extend Kubernetes with the AWS RDA schema and go forward. We want a composition, a composite system that allows us to create more than AWS RDS. What I want to say is that I want a way that we defined a schema that is easy for Joel to define, like what type of database he wants to use, the version, and the size. And we create all the infrastructure around, like, you know, in AWS RDS, you need to create a VPC, you need to create a subnet, a role, a root table. So we want to do all of these things, but we wanted to hide it to the developer. And for that, we need a composable schema, right? At the same time, we want to have this separation of concerns. So it means we have people that is in charge of the infrastructure, so people that knows how the infrastructure works, so how to build a AWS RDS database, but we want to have a developer that only needs to fill just few parameters to get running this application, right? And for that, we brought Crossplane into the platform because Crossplane allows us to create composite resources and composite resource definitions, which are like a group of resources that will be deployed into the cluster, into the platform, right? So this is kind of the definition of RDS claim. You see that Joel is writing the name of the database, the size, the admin, and the secret to be used in the database. And with that, we take care of all the rest of actions, and we make sure that VPCs and everything is created when Joel applies this to the platform API. But this doesn't end here because we have many things thought. We wanted to create also secret management. It's pretty dirty right now. We have to push the secret into the platform API directly. And we would like to integrate with cloud services like AWS Secret Management or Google Service Manager. So we were looking for external secret operator, which allow us to do that in Kubernetes. Also, we had a great idea of creating a project custom resource, which is a Crossplane composition too, that allow us to group all the resources that Joel will need to deploy an app from the beginning. So I can define directly a Git repo, and the Git repo can be based in our template repo, and it can do automatically a pull request to the configuration management repository, and kind of groups all the actions. So we make it super easy for Joel to create a new project. And at the same time, if we include a developer portal, we can integrate this project resource to the developer portal. And then Joel, all things need to do is go to the UI, write fill some inputs, and he will have in some time already the app running, very basic app running in the dev environment, right? Something we also like it is the progressive delivery capabilities. So Flagger is a project that gives us the possibility to implement Canary deployments and other type of deployments too in Kubernetes. And it's the same creator of Flags, so it works very well with Flags. And this is something also we want to bring into the platform. Automatic updates, this is super important because if we are starting creating template repositories and other libraries for the platform, we want to have all the repositories in our organization up to date. And Renovate, which is an example, but it's a bot that allows us to scrape for dependencies updates within our organization and push them as a pull request to all the repositories. So it's great. So takeaways. What I would like that you take to your home today is that usually the technology challenges are not really the problem. Usually it's more the mindset, like what is the platform mindset that you have within your organization, what levels of abstraction you build to make sure that the users that you have, and not the ideal users, the real users that you have, can use the capabilities of this platform, right? For me, it's very important to go step by step and learning through the process. So I don't like to build like the ideal platform for me. I want to build something really basic and then start checking what our users really need, and through the experience, learning, and maybe you make it wrong, maybe you make it right, but go one by one. And as I said at the beginning, it's super important that you treat your platform like a product. So you have a team, and you have a roadmap, and you have features going on, and you have operation of the platform, and you have documentation. So really, treat the platform really like a real team. And then don't use your family as a presentation. I don't think it's a good idea, but well. Everything that I showed you today can be found in this repository. So if you want to give it a try, you can engage with your family this weekend and build your own platform. Thank you.
Thank you for the talk. So first of all, there were many people asking, what did you use for the slide to introduce yourself, where you could see the console showing up?
OK, yeah.
And then we'll talk about the questions on the talk.
Okay. Yeah, this is super funny because I wanted to do with a real cell, but it didn't look well, so I used a CSS builder. So I found an example. I don't know how it's called, the page, but this is kind of these pages where you can put JavaScript, CSS, and it generates a layout. So I used that. There was a built-in
so like
cell.
CodePen or something
like that.
CodePen, yeah. CodePen. OK. Sorry, can you keep it low? Then there are a number of questions regarding when should a company have a platform engineering team? Because maybe you have a small team, and of course the role needs to exist, but it can be a shared role. When should you have a dedicated platform engineering team? Well, it's a big question, but...
Yeah, it's a difficult one, but I guess it depends basically on the size and the requirements of the company. Like, depending on the type of product, if you have everything in the cloud, or you can use a platform as a service that cover all the needs that you have, then I will not create my own platform. But when you are a big company and you have